Hello, welcome to 11.5. If you liked 11.4, you're going to like 11.5. They're basically the same lesson. Here are the answers, by the way, to 11.4. The difference today with 11.5 is that we're going to be dealing with what we call sectors and circles. And what a sector is it's a percentage of the circle, kind of like yesterday, except for we're dealing with area. And so what a sector is, basically, here is a sector. Okay? So area of the circle is pi r squared. Again, we're going to use the pi button on our calculator. You guys probably have seen this formula before. So I'm not going to spend too much time on it. I should probably do one problem now, I suppose. Yeah, I'll find one sample question here. Let's just say that we have a circle and we have the radius is 3. The area would be pi times 9 or 9 pi, or you could type that into your calculator. And again, use the pi button on your calculator. And we'll round to the nearest hundredth, so 28.27 units. Okay, let's get into sectors now. So here's what a sector is, as I just mentioned. Don't worry about all of the vocab for it. It's here. Here's the vocab for you guys. But what we are going to focus on is finding the actual area. And like I said, this is identical to yesterday. The area of the sector, it's a percentage of the entire circle. So all it is you have the area of the sector is some degrees out of 360. It's a percentage out of 360 instead of 100 times the area of the full circle. So the area, that's what it basically is. That's what all of this right here comes down to. Now again, you can use this here, this ratio business, proportion stuff. I'm not going to do that. So what I'm going to do is I'm going to jump into some examples right away, and I think it'll make a little bit of sense, especially if yesterday made sense. So find the area of the sectors. We're just gonna find the red one. The blue one is the same thing, only you're gonna use 360 minus 70, so you lose 290 degrees. So area of the sector equals the percentage. We have 70 out of 360 degrees. That's our percentage right there. Times the area of the full circle, pi, times r squared, and the radius is 8. So we can just type that into our calculator. I'm going to do 8 squared, so 64 times pi, and then I'm going to multiply that by 70, and then I'm going to divide by 360 at the very end. So this is 39.095, so that'd be 39.10. Okay, let's see, we want to use this diagram to find the area of the full circle. Okay, so pi times 14 squared. Well, there's your simple example that I was trying to do before I actually had it. Okay, so this is going to be 615.75. Okay, and then it says the area of the red circle. Again, I'm not going to do the blue one. You can just subtract the full circle from the blue one, or from the red one, or the red one from the whole circle to get the blue one. So the area of the sector equals 120 over 360. So we have 1/3 of the full circle. That's the percentage we're dealing with here. Times the area of the full circle, and I just found the area of the full circle, 615. So we can just take that times 70 or times 120. And then divide that by 360, and that leaves me with 205.25. So if I subtracted that from 615, we can get the blue one. Okay, how about the area of circle V? Here they give us the area, the red area. So the red area of the sector is 35. So here they give us that part there, and then the percentage is 40 out of 360. And then we want the area of the full circle. So instead of putting pi r squared, I'm just going to put the area, because that's the same as pi r squared. That's what I'm looking for. So I'm going to multiply by 360 over 40 to get rid of that. So 360 times 35. And then I'm going to divide that by 40. And 315 is the area, and I guess that would be in square meters. A rectangular wall has an entrance. You want to paint the wall to the nearest square foot. What is the area of the region? Okay, so here what we have going on is I have 36 times, this whole length is 26. This is the area of the full walls, but I'm going to subtract a few pieces there. We have a square 16 by 16, so I'm going to subtract a square there, and then I'm going to subtract half of a circle or a semicircle. So half of pi r squared, but r is interesting. Oh, r is not 10. The diameter is 16, so r is 8. Kind of tricky there. Okay, so if I did that, that's going to give you the area that I'm looking for to paint. So we have the area of the rectangle, we have the area of the square, we have the area of a semicircle. Let's see. I'm not going to do that one because I've already done one like that one. If you know the area and the radius of a sector of a circle, can you find the measure of the arc? Yeah, I think so. Let's see. If you know the area, so the area formula, the area of the sector equals the arc measure divided by 360 times the area of the circle. So if you know the radius, that allows you to find the area of the circle. So we got that. You know this area of the sector. Got that. Can you find the measure of the arc? Yes, because we just call this variable, we'll call that x. And then you'd have this, you have the 360, you have that, and you could find out what the arc measure would be by working backwards. And here's your assignment. I'm going to go over these on our Google Meet. So if you want to look at them ahead of time, great. And if you want to see me solve those, I'm going to go over those. Those are going to be your more challenging questions. So I will see you guys in the Google Meet, and have